Hello everyone, in this video I'm going to do a really quick explanation and do a few practice problems on molality. That's a word that I can't say because I'm so used to saying molarity. I've actually never heard of molality before I took this class. So this is a brand new thing for me, brand new thing for all of us here. I'm going to pronounce it multiple different times wrong throughout this video because I just can't do two L's or two I's, A-L, whatever. Molality. I'm gonna have to say it slow so that I don't say molarity. But molality, not to get mixed up with molarity because they sound so similar. You want to make sure that you are making a big effort in distinguishing between molality and molarity. So similar, very similar calculations as well, but there is a difference between the two. So molarity, what we know before, our good old capital M, is our moles of solute divided by liters of solution. So you have a 0.1 molar solution of hydrochloric acid, which we've worked with in the lab. Then molality is what we're going to use to calculate certain things with solutions, right? So these would be our colligative properties that we're going to go over a little bit more in class, and we went over a little bit already in class, but I'll be going over in a few videos from now. That's why we use molality. Molality. There we go, I think. We use them to do calculations with solutions, right? Where we're going to need kilograms and instead of liters. So, how you would say it, don't say it the way that I say it. Say it the right way, because molality is hard to say. But when you're saying it, for instance, instead of saying 2 molar, you say that it's 2 molal solution, right? So let's say that you have a solution that is 0.75 molal. You would call it 0.75 molal, which means that it has a molality of 0.75. So whatever the moles of solute divided by the kilograms of solvent, it's that. But you say it's 0.75 molal. So let's do a sample calculation of this, and then we'll do a practice one, and that will be the rest of the video. So we have 50 grams of sugar, which we're going to assume is glucose, was added to 250 milliliters of water. What is the molality? Okay, so we're going to need to get moles of the solute. So let's get that first, because right now we're in grams. So we have 50 grams of sugar, which is our solute, divided by 1. And then to get to moles, we're going to do the molar mass. So let's get rid of grams by dividing by grams. Sugar per 1 mole of sugar. All right, let's do that out in our calculator. 50 divided by 180.2. It's going to be 0.27, I'll just say 77 moles of sugar. Just going to underline that because I know I'm going to need that. And then we have to get to kilograms from milliliters. Okay, so 250 milliliters. First, I'm going to get it into liters. So let's do 1,000 milliliters in 1 liter. Actually, I'm going to actually put it into what is density? Density is 1 gram per milliliter, right? Let me just look that up. Density of water. Density of, because we're going to need the density for this. Density of water is about 1 in grams per milliliter. Okay, 1 gram per milliliter. Cool. So 1 gram per milliliter. So I'm actually going to turn it into grams first, and then we'll do the rest of the conversion there. Okay, so in 1 milliliter, there's 1 gram of H2O. This is also H2O. So we can cancel out our milliliters, and we get 250 grams of H2O. Now to do one more conversion to get that into kilograms. In 1 kilogram, there is 1,000 grams. So we're going to divide it by 1,000, which we will get 0.250 grams of water. Oh, not grams, kilograms. Sorry about that. So now we're going to do the moles of the solute. So moles of the solute, moles of sugar. We're going to divide that by the kilograms of the solvent, 0.250 grams of water. And once we do that out in our calculator, 0.277 divided by 0.250, we will get 1.11, I guess we could say. Actually, we'll do correct sig figs. We'll do 1.1, and this will be a little m. So it is a 1.1 molal solution that is made. Okay, so keep in mind, again, we're going to need density for this. I meant to put that in the first slide, but yes, we will need density for this. But I'm going to write it back on that slide. Little note is that for H2O, the density is 1 gram per 1 milliliter. So you'll have to use that during your calculations. Okay, moving on. Oh, why am I doing a star? That's interesting. Oh, because I did paint pencil. There we go. Alrighty. Alright, let's make that note again. 1 gram. That looks like a 7. I'm so sorry about that. 1 gram per 1 milliliter for water. And then the calculation for molal is mole of the solvent divided by kilograms of the solid. This should be solvent. Okay. All right. So what is the molal when 21 grams of KBr is dissolved in 897 grams of water? Okay, so first let's figure out the moles of KBr that's added. So we have 21.1 grams of KBr. I'm going to actually pull up the periodic table for this. So it's just KBr. There's no subscripts, right? It's a K and Br. Yeah, no subscripts there. Okay, so let's add those two molecular weights together. So we have 39.098 plus 79.904, and we'll get 119. So multiply that by, or divide it by 119 grams KBr per 1 mole of KBr. Okay, so 21.1 divided by 119. That'll give us 0.177 moles of KBr. Okay, so now that that's done, let's convert the grams of water to kilograms of water. So we don't need to use our density here because we don't have it in grams. So we will just be doing grams of water to kilograms. So 1 kilogram, there's 1,000 grams. So this will then become 0.897 kilograms of H2O. Sorry if you can hear my dog snoring in the background. So then for molality, we will do the moles of the solute. So 177 moles of KBr. And then divide that by the kilograms of the solvent, so 0.897 kilograms of H2O. And we will get 0.177 divided by 0.897, and it'll be 0.1, well, actually, bring this to point, actually, we can do 3 sig figs. Okay, that's good, so 0.1 molal. I'm just going to check the answer really quick. All right, so we were a little bit off there. That might be just due to like sig figs and things during calculations, but overall everything looks good there, and we will call that done. So thank you all for watching, and I hope this helps, and good luck on your finals if you're watching this during finals week. See ya.